Mark. Here we have a youngster hits a baseball at a velocity of 22 meters per second. Sorry about that. Meters per second. At an angle of 62 degrees. So it's going to go up and come back down somewhere. We want to figure out that how far it's going to travel. So I'm going to try and find dx for this one. Dx, again, is always going to be Vx times the time in the air. Vx is going to be our velocity times the cosine of theta. Time in the air, again, is only based off Vy. Since we're going ground to ground, the time in the air is going to be 2 times the time to go up, which means it is 2 times Vy over g. I'm going to go up and come back down. And then we need Vy, which again is going to be V times the sine of theta. So these are the 4 steps we need to solve this problem. Not too hard. Just kind of plug everything in from here. So this would be 22 times the sine of 62 degrees. And that is going to be 22 sine of 62 is 19 meters per second. So then we can take that, put that into here, 2 times 19 meters per second over 10 meters per second squared gives me 3.8 seconds total that it's going to be in the air for. Vx is going to be the 22 times the cosine of 62 degrees. So 22 times the cosine of 62 is 10 decimal point meters per second. So then our final dx is going to be 10 meters per second times the time in the air of 3.8 seconds will be 38 meters. Now, it's a little bit different from the answer here. It kind of depends on when you do your rounding. So when you get into the lab, you're going to want to be a little bit carry your rounding out at the end, not so much at the beginning or in each of the steps. So try not to round too much. Otherwise, you will miss by giving out because you're doing so many different steps. So try not to round too much early on. Okay? So that is problem number 3.